Okay, this is section 1.2, the rectangular coordinate system. So this also should be pretty well reviewed for most of you. So to graph a linear line, all right, this is pretty straightforward. You can either use slope-intercept form. So if you know that it's mx plus b, I know my y-intercept is 0, negative 1. So then all I have to do is go down 1. And then my slope says 2 over 1, so I can go up 2 over 1, up 2 over 1, and you have yourself a nice straight line. The other option is you always can plot points, so know that you could put negative 1, 0, and 1 in and get the exact same values that I just got done putting in there for you. So that's just a review of how to do that. Okay, x equals 3. If you only have one variable, this is how I teach my algebra kids, every single time, whatever that variable is, that's the answer. So I know this thing crosses the x-axis at 3. And this one will end up being a vertical line. If it's y equals 4, then it would be a horizontal line because every y value would have to be 4. It crosses the y-axis at 4. So those are the two examples of linear lines. Okay, number 3, we're going to jump into quadratics. All right, so just jumping back to Algebra 2, thinking about, all right, inside, that is my h value. Now, I don't know how many of you remember us talking about x minus h squared plus k. Your h and k, that's where your vertex is. The only thing that's moved, since there's no k, that's like a 0. And remember, it's backward sign in here. So what number is actually in there? A positive 2. So our vertex, okay, starts at 2, 0. So I know that it's at 2, 0 is like the bottom of my curve. And then, how many of you remember doing this? Negative 1, 0, 1, 2. And you maybe only did 0, 1, and 2. And you put 0, you get a 0. Get a 1, you get a 1. 2, you get a 4. And then from your vertex, 0, 0. And then 1, 1. And 2 over 1, 2, 3, 4 up. And then you can mirror each of those coordinate points. And you have yourself a nice little parabola. That's pretty neat. Okay, so that's how that works. So if you have a quadratic, you want to find the vertex, and then you can use that idea. So on this one, what's our vertex? Now remember, it's opposite sign for your h and your k. So our vertex ends up being negative 2, 4. All right, so if I go 2 left, 1, 2, 3, 4 up. Now, how does this work? I can do my table again, x, y, 0, 1, 2, 0, 1, 4. Now, most of you should have seen that before. If not, we'll work on it in class. Okay, except this time I have an a value. That's going to affect how wide or narrow my graph's going to be. So I just need to multiply all my y values by 1/4. Well, that's still 0, but instead of 1, 1 times 1/4 is 1/4. 1/4 times 4 is 1. And you kind of disregard this guy now. So you graph the points 0, 0, which is your vertex, because that's your new origin. But now we got to go 1 to the right and 1/4 up. 1 to the right, a 4th up, and I'm going to mirror it. Okay? 2 to the right, 1 up. 1, 2 to the right, and then I'm going to mirror it. This thing is going to end up being quite wide. Oh, instead of the actual normal one that would end up going like this. You're what we call a parent function. Okay, this ends up being pretty wide. Questions on how to do that, we can cover that in class. So if you feel like you're not ready for it, please put a question mark by this problem, and we will definitely do a couple of them in class. Also from Algebra 2, you should know how to, first of all, should recognize this as a circle. Okay, as long as that happens, then we're good. And you might have seen a general form look like this. For a circle, your h and k work the same way as the vertex idea, except it's your center. Well, in this case, there's nothing added or subtracted in here, so I know my center's at 0. And then the one that it's equal to becomes your radius squared. So what number squared is 36? 6 squared. So you know your radius is 6. So from the center, I can go 6 units in each direction. Okay? So I can go 6 to the, oh, that's 5, sorry. That's 6, 6, 6, and 6. And I'm going to attempt to draw myself a handy-dandy little circle. That's close enough, right? But that's the idea. So your center is the origin, and you go 6 in every direction, and that becomes the radius of the circle. Okay, so you're going to be seeing circles. And now why are we doing all this fun stuff? Because we're going to end up solving some systems algebraically. So I do this algebraically. I do not want to graph it at all. So I'm actually going to solve these things. You want to get one of the equations, preferably the line one. If it's a line in a circle, you're not going to want to solve for this x or that y. If you have a linear equation, solve for one of the variables, and we're going to use substitution. So what I usually would do would be add a y and then subtract the 6 back. Now I'm going to jump to this conclusion that you guys can follow me. I'm going to add the y to the right and subtract the 6 back. And solving for y, I get x minus 6. And then what I'm going to do is substitute. Wherever I see a y in my other equation, I'm going to replace it with the x minus 6. So I get x squared plus, here's my y. What am I replacing it with? The x minus 6. And now I want to solve. Now you should get multiple answers now because we have a square, which should be 2 of them. So if I expand this, I'm going to get x squared plus, if I expand the middle here, I get x squared minus 6x plus 36, and that's equal to 36. So what's kind of nice is I can combine these two for a 2x squared. I can combine these two for a minus 12x, and then if you subtract 36 to try to set it equal to 0, your constants go away, so it's equal to 0. Alright, and now just solve. Well, if you have something in common in your two terms, you want to factor it out. So I have a 2 and an x that's in common. And you end up with an x minus 6 equals 0. And if you solve or set them both equal to 0, 2x equals 0, x minus 6 equals 0. So x will be 0 and x will be 6. Now that's at the end because find the intersection means if you actually would graph the line y equals x minus 6, intercepts at negative 6, and if you go slope of 1 over 1, if you actually would graph this guy, you would notice that it's 2 coordinate points. You need to find those 2 coordinate points. Okay? So I have a line. I need to plug in 0. So when I plugged in 0, I got y is negative 6. And then I also need to plug in 6. So then when you plug in that, 6 comma 0, and those are your 2 intersection points of your graph. Sorry, I had another interruption with a student. These 2 would be your intersection points. So when I say find the intersection or solve the system, that's what we're looking for. So make sure you have a coordinate point for when the 2 actually intersect each other. Alright? Distance formula. Now how many of us remember what the distance formula is? Now I could go into a big long thing, but I'm not going to. So if you graph this thing, alright, 4, 7, 1, 2, 3, 4, and then I'm going to go 7 up. And then I have 8, 1. I want to find this distance. Now how do I go about doing that? I like using Pythagorean theorem. That's what the distance formula is. Can you figure out how far it is from this to there? So from 1 up to 7 is 6. Okay? And then from 4 to 8 is 4. And if you use the distance formula or the Pythagorean theorem, same idea. So actually, what is the distance formula? Square root of, and then you can go your x1 minus x2 squared. That is what the distance formula is. You subtract the 2. So if I dump these in, if I say that this is x1, y1, x2, y2, you can just dump it in. So the square root of, and if you do 4 minus 8 squared, and then 7 minus 1 squared, so this is just writing it all out. What is negative 4 squared? Negative 4 squared would be 16 plus, what is 6 squared? That's 36. So I get the square root of 52. Now in this class, in trig, in a higher level class, you need to simplify all radicals as much as possible. So what numbers can, if you kind of break this down, I know it's 13 times 4. I know that's 2 and 2. So I know that I can break out a 2, or square root of 4 is 2. So the best answer would be 2 root 13 is your best answer for the distance between those two coordinate points. Now you're going to need to know the distance formula, but just know that it stems from the Pythagorean theorem. If you graph these points, and you can figure out that, notice that the 4 and the 6 show up on your side, and this is a right angle, you could do the a squared plus b squared equals c squared. That is what the distance formula really is the Pythagorean theorem. Okay. Other parts of this thing talks about angles and standard position. Just know that your vertex of your angle, or the point of it, is always the origin. The initial side we know is always the x-axis positive side. Okay? We needed to get to know quadrants, and then coterminal angles is the idea. So what I'm doing on this slide is just showing you that 315 degrees, if I start here, 90 degrees, 180 degrees, 270 degrees, 45 degrees more, puts me at 315 degrees in the positive direction. Well, coterminal means you share the ending side. Negative 45 just means starting here and going down 45 degrees. Now you go down 45 degrees. This angle inside is still 45 degrees, not necessarily negative 45. Okay, and we'll talk about that in class as well. But these share that same side. That is why they are coterminal. So I might ask you a variety of questions that involve coterminal. So here's a bunch of them that you might have to do in your homework. Can you sketch the angle negative 135 degrees? Well, here's my starting spot. I know it's down 90. 135 would be what? 45 more. So it's cutting this guy right in half. So this is a 135 degree angle, and actually negative 135 degrees to be more specific. Okay? What else does it say? Name the quadrant. How many of you can remember this quadrant? Well, quadrant 1, 2, 3, 4. Okay, so remember that kind of goes in counterclockwise position, so that ends up being in quadrant 3, obviously. So quadrant 3. Part 3 asks, name two other angles coterminal. Here's the easiest thing. Once you actually know this, you literally can add and subtract 360 degrees, because you need to go all the way around the circle again, or go backwards. So, and it's 135, negative 135. If you would add positive 360, okay, that should end up giving you to 225 degrees. So you can check that on your calculator yourself. Or you could subtract 360 degrees as well, and that's just going to tack on negative 495 degrees. And many of you are like, oh my god, how do I graph that? Well, all that means is that you started here, you went around the circle clockwise one time. That's negative 360 degrees, and then you add that 135 on again. So a negative 495 degree angle would just end up being here. These things repeat each other. Alright. So those are the coterminal angles. It says name a point on the terminal side. So what you need to do now is, we're going to go back to our special triangles. So this is what gets kind of interesting. We need to figure out, and we call this our reference angle, but what angle is inside here? And these are going to be nice numbers. This ends up being a 45 degree angle. And if it meets as a 90 degree angle, this is also a 45 degree angle. So you should instantly think special triangle as a 1, 1, square root of 2 idea. And it actually ends up being a negative 1 and a negative 1, because in the third quadrant, the x's are negative and the y's are negative, because we're left and down. And then a coordinate point, well, what is this coordinate point? It can be the distance, negative 1, negative 1. Okay? So that ends up being your coordinate point. and I believe it says find the distance from the origin to that point. All they're saying there is, what is the hypotenuse? What is that side? Square root of 2 is the distance to that point. Okay, so you're using that special triangle, and we're using it in a variety of ways. So here's one more example. I have a 45-degree angle. Okay, for this 45-degree angle, I know that I am just going to go up from my side here 45 degrees, cutting this quadrant in half. And you guys hopefully can be able to do this as well. What quadrant does this lie in? This should be quadrant 1. Because it's the first quadrant, both are positive. Coordinate point, 1, 1, square root of 2, because it's a 45, 45, 90 again. So my coordinate point is 1, 1. And what is my distance? Square root of 2. So that is very similar to that other problem that we just got done doing. So distance is just your hypotenuse. How far is it to the corner here? It just is square root of 2, using Pythagorean theorem or your special triangle ideas. Alright, here's a tough one, 90 degrees. This one gets a lot of you until we kind of think about where we're at. So at 90 degrees, all that means is that we're actually straight up. Okay, now this is going to be what we call a unit circle. I'm going to tell you right now that if you're straight up, your x is 0 left and right. Your y value is going to be 1, called a unit circle. Okay, if we were straight down, it'd be 0 and negative 1. If we were to the left, it's negative 1, 0, 1 unit left, 0 up and down. If we were to the right or at 0 degrees, 1, 0. Okay, these are the quadrant when they lie on the line. Alright, so what quadrant does this 90-degree angle actually fall in? It doesn't fall in one. It's between the quadrant 1 and quadrant 2. So where is it located? The location? Well, what's it falling on? It's on the y-axis. So you need to tell me that. Okay? So if I gave you maybe 180 degrees, like this point would be the x-axis is where it lies on. And that's how you go about doing that. Your coordinate point. What point is it? 0, 1. And what is the distance from the origin up to that point? You're climbing the y-axis. How far are you going? 1 unit. Okay, so we're going to be discussing a few of those as well. So this is going to be your assignment that we will work on in class tomorrow. If you had any questions, any red flags as you went through these notes, please put an asterisk to star by it, and please ask me tomorrow as we are going through those problems to clear up any confusion. And I hope you all have a wonderful day.